Hi, my name is Sudarshan. Welcome to my channel EasyML. In this video, we will look at how we can evaluate regression models. There are two stages of model evaluation when it comes to regression models. First, evaluating model efficiency. Second, evaluating model accuracy. If you can recall from the previous videos, there were two steps to build a regression model: variable selection and splitting data. The model efficiency stage helps evaluate step 1 of building a regression model, which was variable selection. In other words, this stage will help us understand or assess the quality of predictors chosen to predict a particular variable. Now, on the other hand, we have model accuracy. Model accuracy is related to step 2, which is splitting the data. Recall, we split the data into training and testing. At this stage, we are evaluating whether enough data was assigned to the training set. Let us say the split was 60-40. That is, 60% of the data was assigned to the training set and 40% of the data was assigned to the testing set. Here, we assess whether the model was essentially able to learn from 60% of the data that was assigned to the training set. How can we determine whether or not the model was able to learn from the training set? Well, we do so by evaluating the accuracy of the prediction on the testing data set. Let us move on to the first stage in model evaluation, that is model efficiency. Let us say we are predicting height, and let us assume that we have chosen weight as the x variable or the predictor to predict height. When it comes to evaluating model efficiency, we must first take a look at a few key parameters. Here we have three key parameters, namely estimate, significance codes, and R-square. Now let us take a look at the first parameter, that is the estimate. The estimate or the beta estimate is the value that establishes a cause and effect relationship between the predictor and the predicted variable. In this case, given that the predicted variable is height and the predictor is weight, the estimate will determine by how much a change in the value of weight will in turn affect height. In other words, it helps measure how sensitive the predicted variable is to a change in a given predictor. The next parameter is significance codes. When we build regression models in R, we get significance codes. These codes are essentially star ratings assigned to a given predictor. Significance codes will help us assess the quality of the predictors. Here, if the variable weight gets a higher star rating, it implies that it is a good predictor for height. But if it gets a lower star rating, it essentially means that it is a bad predictor. Now let us move on to the last parameter, that is R-square. Let me try and explain this with an example. Let us say if someone had to describe me, how would they do that? They will first try and highlight certain key aspects that are idiosyncratic or particular to me, right? Now let us say when they had to describe me, they start with a generic parameter such as gender, that is, gender is equal to male. This does not help as such because there are 3.8 billion people in the whole wide world whose gender is male. Now, they go on to add another parameter related to my location, that is, country is equal to India. Well, now from 3.8 billion, the location parameter has narrowed it down to about 600 million people. If they decide to tweak the location parameter further by adding the city I live in, which in this case is Mumbai, well, this further narrows it down to about 10 million people. Now, they add the parameter name, which is Sudarshan. Then they go on to add another parameter, which is education. Well, I did my BA Economics and my MSc Analytics from the UK. Then they further decide to add yet another parameter, which is employment. Well, I currently work as a data scientist in the airline domain. Now, adding all these parameters, I get the following description. A male data scientist who works in the airline domain and currently resides in Mumbai and is equipped with a bachelor's and master's degree from the UK. The people who fit this criteria or this description are definitely a smaller subset. Therefore, the more parameters someone adds to describe me, the better it would be for you to understand me, right? This is what the R-square value helps measure. The R-square value measures how much percentage of variation in the predicted variable is explained by the chosen predictors. It is important to note that since the R-square is measured in percentage, the value of R-square will naturally lie between 0 to 100. 0 means that the chosen predictors are unable to explain the predicted variable, and 100 means that the chosen predictors are being able to perfectly explain the predicted variable. In the example where someone had to describe me, well, when they started with gender, it is likely that the R-square value would have been extremely low. But as and when they kept adding more and more parameters to describe me, it is likely that the R-square value would have gradually increased. Like in this example, I have chosen weight. Let us assume that the R-square was 60%. This means that the variable weight is accounting for or is able to explain 60% of the variation in height. Now, let us say I add another variable called age. We can now see that the R-square value has increased to 80%, which is good because both age and weight together can now account for or can explain 80% of the variation in height. Well, at this stage, it is important to note that when we are adding predictors, we need to ensure that the predictors are not redundant because this could lead to an artificial increase in the R-square. Now, don't get worried as such because we will examine each of these parameters in greater detail when we build the regression model in R. In the next video, we will look at the second stage of model evaluation, which is model accuracy. Thank you. Stay tuned.